So good morning dear students. So welcome to the next session of engineering drawing. So in the last class what we have studied, so we have studied about the plane scale. Today we will discuss about the diagonal scale, correct? So last class में okay plane scale. Diagonal scale, see, it can measure up to 2 decimal point, that is it can measure yes, very good morning everyone. That is it can measure units, subunits and subdivision of subunits. Like meter, decimeter, centimeter, yard, feet, inch, etc. Isn't it? So 3 decimal points. Sorry, 2 decimal point. So one will be unit, another subunit, subdivision of subunit. For example, now let us understand how it is possible. Suppose we have to measure, let us say 1.76 centimeter, 1.76 meter, correct. So let us take an example how we are going to measure 1.76. So for this what we do, let us say 1.76 we have to measure, right. So so let us 1.76 we have to measure, right. So let us say that this is 0, this is 1, this is meter, right. So here we will put units, here we are going to put subunits, correct, units and subunits, right. So put it like this. Now this what we are going to do is we are going to divide this subunits into 10 equal parts. Why? Because so that one part will become decimeter. So if this is meter, so this part it will become decimeter, isn't it? So if that is your meter, right, so this part it will be a decimeter. So if this is unit, so this will be your subunits, right. So let us say we are going to divide it into 10 equal parts. right? See, so we have divided the whole part into 10 equal parts. So let us say this is 0, fine. So this is the first division, 1, 2, 3, 4, 5, 6, 7, 8, 9 and total 10. So if I consider this point to be suppose A and if I consider this point to be B, so if I ask you what is the distance between these two, you will say it is 1 decimeter. 1 decimeter, which is same as 10 centimeter, isn't it? So I have converted meter and decimeter. Now I want centimeter because we have to measure 1.76 meter. So this is meter, this is decimeter, and we want to find one more unit, that should be a centimeter, then only you will get the 1.76 meter, right? So 1 meter, meter, decimeter and centimeter will be there, right? Okay. So let us see how to do this, fine. So for this, what I will do is, let us say fine. So this point is your A, this point is your B and this point is your O, correct? So this distance is how much? It is 10 centimeter. That means what I have done, I have redraw, right? Redraw. What I have redrawn? I have redrawn A, B and O, correct? So this is A, this is B and this is O. So A, B, O has been drawn, right? You can see that this is A, this is B and this is your O, fine. So what is the length of AB? It is 10 centimeter. So length of AB is how much? It is 10 centimeter. So from this decimeter, I have to make it in centimeter, isn't it? So from decimeter, I want centimeter. So what I will do is, see how to convert this decimeter scale into centimeter scale. So I have considered ABO, and ABO I have joined it with a line so that it becomes a triangle. That means if I can show you here, right? So what I have done? So I have done like this, something like this, right? So the same triangle you can see over here, isn't it? So this is the same triangle that I have drawn here. Now what I am going to do is, so I am going to convert the decimeter into centimeter. So I will divide it into 10 equal parts, right? So let us say this is 9, 8, 7, 6, 5, 4, 3, 2, 1, correct? So let us say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? So that means I have divided this triangle into 10 equal parts. Why I have done with the 10 equal parts? Because from centimeter to from decimeter to centimeter there are 10 divisions, right? So 10 division of decimeter will give you 1 centimeter. Now if I ask you what is this length, 1O, you will say that it is 1/10 of BO, isn't it? So what is this length? So 1O, it is nothing but your 1/10 of BO, correct? Now what you can observe here is what you can observe here, this one, okay, let us say, let us name it 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash and 9 dash, correct? Fine. So what I have done? I have done the main scale, right? So we have main scale, we have subdivision of the scale, or we can say that units, subunits, and I am going to find the subdivision of subunits, right? So for this I have done like this. Now you can see that the triangle 1 dash 1 O, that means this triangle, isn't it? It is similar to triangle ABO. Agree to this, isn't it? So triangle 1 dash 1 O is similar to triangle ABO. So if it is a matter, so therefore I can say that 1 dash 1 upon AB is equal to 1 0 upon B0. So 1 dash 1 upon AB is equal to 1 0. Okay, what is the value of 1 0? So 1 0 is nothing but your BO by 10, isn't it? What is the value of 1 0? Is 1/10 of BO, right? So into 1 by BO. This is nothing but your 1 by 10, correct? So what is the value of 1 dash 1? 1 dash 1 is equal to AB by 10, isn't it? And what is your AB? AB is equal to 10 centimeter. So this is equal to 10 centimeter divided by 10, which is equal to 1 centimeter, right? So what you can observe here, is what you can observe here, 1 dash 1 is how much? 1 centimeter. That means 1 dash 1, it will be your 1 centimeter. Similarly 2 dash 2 will be how much? It will become 2 centimeter, isn't it? 1 dash 1 is how much? It is 1 centimeter. 1 dash 1 कितना है? 1 centimeter है ना. Similarly how much will be 2 dash 2? 2 centimeter. This will become 3 centimeter. This will become 4 centimeter. This will become 5 centimeter. This will become 6 centimeter. This is 7 centimeter, 8 centimeter, finally 9 centimeter, and from here to here. That means from 1 to here, this is 1 centimeter, right? So from, if I consider this to be the reference, so from here this distance will be 1. From here this distance is 2, 3, 4, 5, 6, 7, 8, 9, and finally from here to here it is 10 centimeter, right? So this is how we have got it, right? So that is why it is also known as diagonal division. So from here only the name came, diagonal division. I hope it is clear. Now write it down. So when you complete it, then we will go for making this scale. Done. See, for similarity of the triangle, so from the concept of similarity of triangle, this is 1 dash 1 O and ABO, these are similar. So 1 dash 1 upon AB will be equal to 1 0 upon B 0. Similarly, that will be equal to 1 dash 0 or 1 dash O upon AO, correct? So that is the property of the similarity triangle, right? And this length will be how much? It will be 1/10 of BO. Fine. Done. Okay. So what you need to do is, now this is one triangle you have drawn. So similarly, if I draw parallel lines like this, so that means for this to make 1 decimeter into centimeters, so I have to draw 10 equal divisions, right? So 10 equal division means what? So let us say this is 9, 8, 7, 6, 5, 4, 3, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. You can see that this is how much? 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter, 6 centimeter, 7, 8, 9 and this is your 10 centimeter, right? So from here, that means from this reference, if you check 1 centimeter, 2 centimeter, 3, 4, 5, 6, 7, that means this will become how much? It is your 1 centimeter, 2 centimeter and so on. So similarly, what I can do is, similarly, if I draw this kind of parallel, so this is what is called as diagonal, right? So if I draw line parallel to each other like this, if I draw line parallel to each other like this, so you will get multiple values. Correct? So if I draw like this, so now it has become diagonal scale. Now how much we have to measure? We need to measure 1.76, right? So how you will measure 1.76 in this figure? 1.76. So up to here it is how much? It is 1 meter, 1.7. So first check where is 1.7. So 1.7 is up to here, isn't it? So 1.7. So this will become 1.71, 1.72, 1.73, 1.74, 1.75 and this is a 1.76, because till here it is 1.7, 1.71, 1.72, 73. So this is your 76. So that means from here if I draw, right, so from here if I draw a line like this, so this distance is at 1.76 meter. Check it out. (110) of BO. This is 110 BO, because this length is how much? It is 1/10 of BO. Total length is BO, so 1/10 of BO. Done everyone? This is a reference. रोहित शर्मा सर 10 का 10 का वैल्यू 10 का वैल्यू 1/10 10 बराबर भागों में डिवाइड करने पर आएगा। हाँ बिल्कुल बिल्कुल वही तो आएगा। है ना? ठीक है रोहित? डन एवरीवन? चलो हो गया। डन एवरीवन? Done. Okay. So what are the points? Some note. Diagonal scale is based on principle of similarity of triangle. Principle of similarity of triangle. Principle of similarity of triangle. Correct? So because diagonal scale, you can see that similarity of the triangle, because diagonal scale is formed from making number of triangles to be similar. Similarly, second point, least count of diagonal scale. Least count of diagonal scale. How to find it? First, there is a term, it is called as primary division. Primary division, right? So primary division is nothing but your main scale division. Main scale division, and it is denoted by n1. Correct? So for here example, here what is the main scale division? So you can see that this is the whole scale, this is the total scale. So this scale has been divided into two major group. One is 0 to 1, another is 0 to this 10. So this is a 1 and this is a 2. So main scale division, that means the whole scale has been divided into two parts. So one part is towards the unit, another part is towards the subunit. So how many division? So here only one division is there, here one more division, so two divisions. So here example, here n1 is how much? It is equal to 2. Correct? That is your primary division. Second is your secondary division. Second is your secondary division. It is equal to subdivision of primary scale, main scale. This is your subdivision of main scale, and it is denoted by N2. So here if I ask you what is the, as example, what is the value of N2? So subdivision of main scale, see this is the main scale, so subdivision, how many division you have done? 10 divisions, right? So 0, right, 1, 2, 3 and up to 10. So how many divisions are? Divisions are 10. So here N2 value is how much? It is 10, correct? Similarly, we have diagonal division. What is your diagonal division? So diagonal division means it is your subdivision of secondary division. Subdivision of secondary division, and it is denoted by N3. So here as an example, if I talk, what is the value of N3? So N3 means we have to subdivide the secondary division. So you can see that this secondary divisions, right? So whole secondary division has been divided into how many groups? So this is again 10, right? So 0, 1, 2 up to 10, right? So 10 equal divisions. So here N3 is equal to how much? It is 10, correct? So that means what I want to say is, suppose these are the divisions, right? So here these are the units, this is the subunit, right? Or if I can show you here, this whole thing is your N3, right? This whole thing is your N2, and this whole thing is your N1. Now it is clear, right? N1, so this is N2 and this is your N3, clear? Fine. So therefore, okay, so these are the few divisions. Now we say technical or we can say that if L is maximum length of scale, maximum length of diagonal scale, length of diagonal scale, then least count of diagonal scale is given as L upon N1 into N2 into N3. So this is the formula, right? सचिन सर नाइक सर कितने स्लाइड्स हो गए अब तक? आई थिंक 2 स्लाइड्स हो गए. ओके, सो लेट अस डू वन क्वेश्चन फ्रॉम योर वर्क बुक, है ना? एक आध क्वेश्चन करवा देते हैं, जो हल्के हैं वो तो बन जाएंगे, जिसमें थोड़ा सा सोचने वाली चीज़ है. सो द सम क्वेश्चंस आर देयर विच रिक्वायर्स अ लिटिल मोर अंडरस्टैंडिंग. So page number 6, question number 2.28. Page number 6, question number 2.28. It is saying that a diagonal scale of RF1, RF is equal to 1 means x upon y is equal to 1 means drawing length is equal to actual length, correct. So, drawing length and actual length both are same. Maximum distance is 10 centimeter. Maximum distance is 10 centimeter means what? So, this is 0, 1, this is 10, sorry, 9, 8, 7. This is your unit. So, this will be your subunit, isn't it? So, 10 division like this, isn't it? Fine. Now, what it is saying that the maximum distance to be measured is 10 centimeters. So, what is the total distance you can see? So, the total distance is how much? So, this total distance is your 10 centimeter, right. So, you can see that the actual length and drawing length both are same. Actual length and drawing length is same. So, drawing length is given as, so actual length is 10 centimeter. So, the drawing length will be also 10 centimeter. So, out of 10 centimeter from 0 to 9 and here 10. So, total 10 centimeter. So, they are asking what is the least count, right. So, here what is the value of n1, right. So, from here to here it will be n1, this is your n1. So, how much is your n1? So, total 9 division here and 1. So, n1 is how much here? 10. What is the value of n2, right. So, this is your n2, n2 is, sorry, this is your n2, isn't it? So, n1 means you can see the main scale division, here 9 division, here 1 more. So, 10 division n1, n2 is how much? n2 is 10. How much is your n3? n3 means this is the division that you have to do, right. So, this is your n3, isn't it? So, how much is the n3? n3 will be also 10. So, therefore, what is the least count? It is equal to 10 centimeter divided by 10 into 10 into 10. 10 centimeter means 100 millimeter divided by 1000, 0.1 millimeter. B. Clear everyone? Yes, Saurav, Prashant, correct. क्लियर? ओके प्रशांत सर इसमें N1 10 कैसे आएगा? देखो क्वेश्चन में कितना दिया है? एक्चुअल लेंथ. इन क्वेश्चन एक्चुअल लेंथ and drawing length it will be same because RF is 1. So 10 centimeter, 10 centimeter you have to draw. So if you have to draw the 10 centimeter, right, so 10 centimeter means what? This is 0, this will be 1 2 3 4 5 6. So this is 1 2 3 4 5 6, so 7 8 9, correct? So these are the units. This will be your subunits. So right, so how many divisions you have done? So here 9 and here total 10 divisions. So this is your N2, correct? This total will give you N1. So how many division? 1 2 3 4 5 6 7 8 9 and one more here, this one. So 10 divisions. Clear? Isn't it? Total, that is what I have told, no? What is N1? N1 is your main scale division. That means scale has been divided in how many equal parts? These parts are all equal. This part, right? So that means this part, right? This part and this part length is exactly same. This part, this part. So how many total division will be there? So there will be 10 equal divisions, isn't it? Clear? क्लियर एवरीवन? शैल वी मूव फॉरवर्ड? बताओ क्लियर हो गया कि नहीं? है तो टोटली डिस्टेंस कितना? 10 सेंटीमीटर हो गया ना? दिस टोटल डिस्टेंस इज हाउ मच? इट इज योर 10 सेंटीमीटर ओनली. क्लियर? कार्तिक? So third is your vernier scale. It is similar to diagonal scale. It is similar to diagonal scale that can measure up to 2 decimal points. That can measure up to 2 decimal points, right? It is of two types. Number one, it is called as direct or forward vernier. Correct? So direct or forward vernier. So direct और forward vernier क्या होता है? Say this is 0, right? 9. So this is the plane scale. This is your plane scale, correct? And we mount one small scale This is called as vernier scale. Correct. So here 0 and 10. Correct. That means, it means that this is your 9 main scale division and this is your 10 vernier scale division. Correct. So 10 vernier scale division coincides with 9 main scale division of the main scale. So if I consider this to be suppose n VSD, so this will be how much? It is your n minus 1 MSD. Right. So what is MSD? MSD is your main scale division. Main scale division. Correct. And what is VSD? So VSD is your vernier scale division. Vernier scale division. Right. Main scale division and vernier scale division. Correct. Right. So what I can say is, I can say that length of n vernier scale division is equal to length of n minus 1 main scale division. So this implies 1 vernier scale division is equal to n minus 1 upon n main scale division, which is equal to 1 main scale division minus of main scale division upon n. Correct. So therefore we define least count as MSD minus VSD, MSD minus VSD, which is equal to MSD upon n. Right. So what is with the scale ratio, how much? What is the scale ratio? Scale ratio is n minus 1 n. Scale ratio. Correct. So you can see that what is the scale ratio? Scale ratio is here n minus 1 and here it is n. So in the exam they will ask you what is the scale ratio of forward or direct vernier. So it is n minus 1 n, or what is the least count. So these are the two questions that they will ask you, if at all they asks. Correct. So this is your basically direct vernier. Fine. Second one is called as backward or retrograde vernier. Backward or retrograde vernier. Fine. So note till here, then we will go ahead. ठीक है. Backward and retrograde vernier, what is this? say this is 0, 10. This is your plane scale. Fine. So this is 0 and this is 10. So this is the vernier scale. Correct. So here what you can observe, that here one extra division is there, isn't it? So this extra is nothing but your 11th. Fine. So I can say that this is your 11 main scale division and this is your 10 vernier scale division. So if I call it to be n vernier scale division, so it will become n plus 1 MSD, isn't it? Fine. So the difference between forward and backward is, in the forward the calibration is done in the forward direction from left to right, and here n division here will be n minus 1, but here the calibration done in the backward direction. So the name is backward or retrograde vernier, right? Okay. So here again I can say that length of n vernier scale division is equal to length of n plus 1 main scale division, isn't it? So this implies 1 vernier scale division will be how much? N plus 1 upon n MSD, which is same as 1 MSD plus MSD upon n. So therefore we define least count as VSD minus MSD, which is again coming to be MSD upon n. So this is the least count. With scale ratio how much? So with scale ratio n plus 1 is to n. So these are the two questions that they will be asking you about the vernier. Correct. So these are the two types of vernier. See, what we are learning is from the objective point of view, because we don't have to construct it on the drawing sheet, right? So because we are not in the college, so that we can understand a more in depth. So in the examination what they are going to ask, what that we are only learning, right? So in the crisp way we are learning the points or the factual points what they are going to ask in the exam. So in the examination they will ask you what is the least count of the backward or retrograde vernier, or they might ask you what is the scale ratio of retrograde or backward vernier. So this type of question they will ask you. Fine. Fourth is your corresponding or comparative scale, or comparative scale. Correct. So what is corresponding? So it has common RF, okay, or you can say that it can be either diagonal or vernier scale, diagonal or vernier scale. It can be either diagonal or vernier scale having common RF, having common RF, but calibrated to measure different units, to measure different units like kilometer, mile, or feet, centimeter, etc. So if you want to compare, or if you want to have the two different units and we have to measure it, then we go for the comparative or corresponding scale. So what in the examination, what they will ask you? They will ask you what is, on what basis the corresponding or comparative scale is made. So on what basis? On making common RF, right? So both the scale will have common RF. So whatever the RF or representative fraction used for corresponding for the kilometer, the same RF will be used for mile, right? So kilometer RF and mile RF, it will be same, correct? And the last one, fifth one, it is called a scale of chords, right? So with this we will finish this chapter also. Scale of chords, it is used to either measure or make an angle in absence of protractor, angle in absence of protractor. So we know that protractor is used to measure the angle. Suppose you have to make 30 degree or you have to measure certain angle, we have the protractor. But suppose you don't have the protractor and you want to measure or you want to make the angle, then you have to use scale of chords, correct? So these are the thing that you have to learn. So you don't have to know how कैसे measure करता है, how to do it. I can show you the example, but it is not required because the time is not that much to, so that you can have a deep analysis on it, right? Okay, write it down. Then we will go for the next chapter, chapter number 3. So Rohan Chaudhary, listen, Rohan Chaudhary, RF concept of comparative. See, suppose you want to measure kilometer or you want to compare kilometer with the mile, right? So 1 kilometer around 1.63, right? So 1.63 kilometer is 1 mile. So दोनों के लिए जो स्केल बनाओगे दोनों का RF सेम होगा. That means for kilometer and for the mile the same RF has to be used, right? But the calibration will be different, correct? So coming to the next chapter, chapter number 3, conic section. Right? So conic section, in the conic section we have two categories. First, conic section defined as section of cone. Correct? So first one is your conic section defined as section of cone. So what is the meaning of this? So sectioning means to cut, isn't it? So I told you yesterday, section line or hatching line. Section means काट दो. Why? To reveal the internal structure. अगर मान लो ह्यूमन बॉडी के अंदर देखना है तो आदमी को काट दो. So if you cut the human, you will get the internal organs. So until unless you slice it or section it or cut it, you cannot reveal the internal structure, right? So there are two things that we are going to fine. So conic section defined as section of cone. Now see, so first let us develop a basic concept, correct? So what is the basic concept? Correct. Basic concept, generation of a cone. How to generate a cone? See, suppose consider, suppose this is an axis, right, and this is a triangular plane which is rotated with a very high speed, correct? So conic section defined as section of cone, that means section of cone. So sectioning means what? To cut a cone at various angles. Slowly you will come to know. So first let us develop how a cone is generated, right? So in conic section we have two parts that we are going to study. The first part we have, that is conic section defined as section of cone, and second part we will have the conic section defined as locus of point, that means mathematically as well as model wise. So conic section defined as section of cone means what? We have a cone and we are going to slice the cone at various angles, and what are the shape that we are going to get, that is called as conic section, right? So for understanding the conic sections, so first of all we have to understand how to generate a cone, how a cone is formed. After that only we can do it. So for this what I am doing is, I am taking one triangle and I am rotating with certain angular speed omega, correct? Omega. Let us consider there is a point over here P at t is equal to 0. Right. So after rotation what you will see? After rotation what you are going to see is, correct? So this is the axis, right? So here this was the point, correct? So this was the point P at t is equal to 0. After some time what is going to happen? So after some time this right, this point will come over here at t equal to t1, at t1. After some time what is going to happen? After some time this point is going to come over here, isn't it? So this point will come over here, P at P2, right? After some time what is going to happen? So after some time this point will be like this, isn't it? This will become the point P at T3, isn't it? So these are the basically, so this is how the point will rotate. Similarly inside, so therefore what I can say that, I am going to get a cone, right? So I am going to get a cone. Which type of cone you are going to get? So this will be your axis, right? So I am going to get a cone like this. This cone is called as right circular cone, right? So these are the hypotenuse that is going to happen, or that you will see. Correct. So this cone, you can see that this axis, it is making how much angle? 90 degree. So that is why the word it is used is right. How is the base? So base is your circular, and what is the shape of the object? It is cone. So that is why it is called as right circular cone. Right circular cone means what? This axis is making 90 degree with the base, and what is the shape of the base? Circular. If I say right elliptical cone, so the base will be your elliptical, right? So this is axis. Now there are few names. This is called as apex. This is called as apex. These lines are called as generators. These lines are called as generator, correct? And this one, it is called as base. Fine. Now one thing that we can observe here, if I say that alpha is the angle, right? If alpha is this angle, so here what will be the alpha? This will be your alpha. And here what will be your alpha? So this will be your alpha. So what is your alpha? Alpha is your semi apex angle. Semi apex angle, isn't it? So this is how generation of cone. So this is how the cone is formed. Clear? So first note it down. जब तक आप नोट करो तब तक मैं I will enjoy my tea, cup of tea. So done everyone? Dekho. Now see. See, this is how a cone is basically formed, isn't it? So this is how a cone is formed. So when a triangular plane rotates at a certain angular speed, right? So what you can see that, what is this? Okay, so let me change the color. What is this angle? Alpha, isn't it? So this alpha is called as semi-apex angle, right? So what is this alpha? Alpha is your semi-apex angle, isn't it? Now what I am going to do is, I am going to cut this cone at various angles, and I will show you what are the shapes that we are going to obtain. So such type of section is called as conic section, right? So you can see that the hypotenuse, is constantly rotating with certain speed, isn't it? So this is called as conic section. This is how the cone is formed. Right circular cone, you can say that this is making how much angle? It is making 90 degree, isn't it? So it is making 90 degree. I hope it is clear. Fine. Okay. Now what is the meaning of conic section? Let us see. If you see that in this particular diagram, you can see that a cone has been cut into various parts. This is called as conic section. Sectioning means to cut a cone into various parts. So sectioning of cone means cutting a cone into various parts. So sectioning. So you can see that in this particular case there is a cone, and this is the axis. You can see it very clearly, and you can see that this axis, that means the cutting plane, is cutting it exactly parallel to the base, right? So this cutting plane is parallel to the base, so the shape you are going to get, it is called as circle. Similarly, if it is the cutting plane, if it makes certain angle with the axis, right? So here you can see that this axis is making 90 degrees, so it is your circle. If it is making certain angle, right, if it is making certain angle alpha or some angle, so you can see that it is an ellipse. But this cutting plane and this edge of the generator, now these two are parallel, then you are going to get parabola. And if it is less than, then you are going to get hyperbola, right? So this shape is your ellipse, this shape is your circle, this shape is your parabola, and this shape is nothing but your hyperbola, right? So this is what we are going to make it now. Fine. So this is what we are going to construct, and let us see how to do it. Correct. So circle, ellipse, parabola, as well as hyperbola. Fine. Now see very carefully. So conic section. So the first one I am going to make what? Circle, right? So the first one, let us see how to make the conic section with a circle, right? So for this, what I will do is, first of all I have to make a cone. So let me make few copies of it, because I will be requiring it. Correct. Now see, the first one I am going to draw a circle. Now for circle, what I have to do is, now see very carefully. This is the basically cone. Now what is this angle? you will say that this is semi apex angle, right. So this angle is how much? You will say this angle is your alpha, correct. Now to draw the circle, what I have to do is, now see very carefully. I hope everybody is able to understand and everybody can visualize this figure. See, if I see, this is the cone and you can see that this is the cutting plane. So this cutting plane is exactly parallel to the base of the cone, isn't it? This is the base of the cone, circular base. So this is the section plane. This is called a section plane because this plane is going to section it or it is going to cut it. So this plane is parallel to the base. So that means from the front it will look like a line. So this is how you can see that, right? Fine. So let me draw it here. So let me draw it. See very carefully. So how I am going to cut it? So I am going to cut parallel to the base, right. So you can say that this side and this base is parallel to each other, isn't it? So you can see that this cutting plane, which is look like a line, this plane will look like a line. So this is parallel to the base, right. So now let me complete it. Correct. So you can see that this is the cutting plane which is made like this, correct. So first you draw the line. So this line is parallel to the base. Now you complete the plane, right. So what is the shape you are going to get, right. So what is the shape you are going to get? So here if you see here, so what is the shape you are going to get? So I will draw it with free hand, right. So the shape, this is the shape you are going to get. How? See here very carefully. This is the shape you are going to get, circle. How? See, this is the cone. When I am going to cut the cone by this cutting plane, so I am going to remove the upper part, right. So I have removed the upper part, I have removed this paper. Now see what is the shape you are going to get. So obviously this is a circle, right. So that is the figure that I have shown you also, isn't it? You can see that the same figure here. So you can see that when the cutting plane is like this parallel to the base, so you are going to get a circle. The same thing you are going to get it here also, isn't it? Same चीज आपको नजर आ रहा है. So it is a circle, right. If I consider if I say this angle is beta, that means this angle, if I say this is beta, so what is the condition? If I say that at beta is equal to 90 degree, that is cutting plane or section plane, that is cutting plane or section plane parallel to section plane parallel to the base, parallel to the base. This is the condition, right. So this is the condition, isn't it? So if I put this condition, then I am going to get a circle. Agree to this point, isn't it? So at beta is equal to 90, that is cutting plane or section plane parallel to the base, you are going to get a circle. I hope it is clear everyone. Okay. Right. So in a single slide I will show you two circle, the second one I will show you here ellipse. This angle is how much? It is अल्फा। बताओ यहां तक क्लियर है सबको? Clear? So this is shown by the hatching line, right? So this is the shape you are going to get a circle. So with, and these lines are basically called as hatching line, isn't it? So you are going to get a circle. Clear everyone? बताओ समझ में आ गया? Now for ellipse, now see. Okay. See, for ellipse, this is again the cone, right? Now you can see that this section plane is making certain angle with the axis. So if this is the axis, this section plane is making certain angle with this axis, isn't it? So it is inclined somewhat. So therefore what I can do is here, so let us incline it like this, correct? So you can see that this angle is now beta, right? This angle is your beta, correct? So this angle is your beta. So what is the condition? So here you can see that this beta is greater than alpha but less than 90 degree, isn't it? Here you can see that beta is 90 degree, so I have just tilted it. So beta is now less than 90 degree but it is greater than alpha. That is the condition, right? So this is the condition. This is the condition, correct? So if it is the case, then now let us complete it. Correct? Or you can just wait. Something like this, right? Fine. So you can see that from front it will look like a straight line. If I tilt a little bit, so you will see a plane. Now let me remove this portion. When I am removing this portion and if I show you like this, so what is the shape you are going to get? So this is nothing but your ellipse, isn't it? So what is the shape? So the shape I am going to get is an ellipse, correct? So this is one point, this is another point. This is the hatching line. So internal structure is revealed, right? So this is your ellipse. Clear? Clear everyone? So this is how we are going to get ellipse. So this is the second case done. So the same thing I have shown you here also, the same thing is your ellipse, correct? Same thing is here. Done? Third, parabola. Correct? This angle is your alpha. Now for parabola, what I am going to do is, so for parabola, see, you have to make a line parallel to one of the generator, right? That means this is parallel to one of the generator. So this angle, if I call it as beta, so beta and alpha, it will be same, because if this is beta, right, so if I shift it, so that means this beta and this alpha, it will be same. Why? Because this alpha is the angle made by this generator and the axis. Generator और axis के बीच का angle alpha है. Similarly, so this is parallel to generator, so this beta and alpha will be same, right? So what is the condition? Condition for parabola, correct? Condition for parabola, beta is equal to alpha, that is cutting plane or section plane, cutting plane or section plane is parallel to one of its generator, parallel to one of its end generator. Clear? Okay. So that means the situation is similar to this. See here, you can see that this cutting plane or section plane, this plane is parallel to, sorry, you can see that this section plane is parallel to the generator. So this is end generator. So if I put the marker over here, so this marker and this plane both are parallel to each other, you can check it yourself. So this is the condition for the parabola, right? So when you have drawn a figure like this, right, so you can see that this is how it is done, right? So this is parallel to one of the end generator, correct? See the figure and see this one. So plane will look like a line. So if I tilt you a little bit or tilt this figure a little bit or model this like this, so you can see that this is a shape. So let me complete this shape, right? Right, something like this, isn't it? Correct? Now let us see how to draw the parabola here. सवाल ये है कि पैराबोला कैसे बनाओगे इसके अंदर. Fine. So you can see that this is a section, right? So this is the section you are going to get. Correct. So this is the section. Correct. Now see how to draw this parabola. करेक्ट, बताओ यहाँ तक क्लियर है? यहाँ तक ड्रॉ कर लीजिए पहले. तो देखो, you can see that this cutting plane, right? So let me show you a little. Fine. See, this cutting plane, you can see that it is cutting the one base. So this is the base, it is cutting here vertically opposite, that is vertically, or you can say that it is exactly diagonally, not diagonally, vertically opposite point. So that means when this section plane is inserted here, so you can see that there are two cutting points. One cutting point is at this, the point is here at the base, another is exactly perpendicular or vertically opposite to here. That means when this plane is going to cut, so it is cutting the one base and another point is exactly opposite, vertically opposite, isn't it? So one point is here, another point is vertically opposite, isn't it? You can see that this is the cutting plane, so here and exactly vertically opposite. Another point of intersection is here, right here. So if I remove this one, correct, if I remove this one, you can see that this is a parabola. So if I remove it, you can see that this is a parabola. So these are the 2 points where it was cutting, and another curve is there. You can see that there is a curve. It is not a point, it is just a curve at this particular point. That means where it is inserting. So when I am inserting this section plane over here, so it is going to slice this point. So here, what is that point? So this point is shown by this one, isn't it? So this is where it is slicing. So here you can see that there is a smooth curve that is formed, isn't it? So there is a smooth curve that is formed, right? So if I draw this one, so I am going to get shape like this. So this shape is basically called as parabola, hatching lines, isn't it? You can see that the shape. So there is a smooth curve that is formed, right? So 2 point here, 1 point from where this is inserted. So this point will sliced, right? So this is the slice. So this is nothing but your parabola. Clear? Okay. Sumit Sharma, sir, which subject is this? Is this first class? No. This is the second class and the subject is design, drawing and safety. So we are covering drawing part first. We are covering drawing part first. Clear? So I hope the parabola is now clear. So please draw it, and then the fourth one will be your hyperbola. ठीक है, बताओ समझ में आ रहा है कि नहीं? Are you able to visualize it? Are you able to understand it? नहीं रोहित शर्मा, जरूरी नहीं है। ये जो ऑपोजिट साइड से जो पास हो रहा है, जरूरी नहीं है कि वो किस पे पास कर जाए, ये जरूरी नहीं है कि वो सेंटर से पास करे। इट इज नॉट इंपॉर्टेंट, है ना। ये शिफ्टिंग पे डिपेंड करे, कितना आप प्लेन को आगे ले जा रहे हो और कितना पीछे ले जा रहे हो, उसके हिसाब से कट करेगा, राइट। सो अगर आप देखो, एक ऐसा पॉइंट आएगा जब ये बिल्कुल सेंटर से भी पास कर सकता है, मीन्स बिल्कुल सर्कल के डायमीटर को भी कट कर सकता है, राइट। तो जैसे मेरे पास जो इफ यू सी हियर, ये मेरे पास जो पैराबोला, इसमें एग्जैक्टली दोनों इक्वल हाफ पे कटा हुआ है, राइट। ये देखो, ये यानी कि ये एग्जैक्टली डायमीटर से, जरूरी नहीं कि हमेशा डायमीटर से हो। अगर इस प्लेन को थोड़ा सा इधर और शिफ्ट कर दोगे, है ना, देखो ये कटिंग प्लेन है ना, ये कटिंग प्लेन को ऐसे हम लोग डाले हैं कि ये बिल्कुल यहां से डायगोनली, मतलब डायमीटर को कट कर रहा है, लेकिन जरूरी नहीं कि हमेशा कट करे। इसको जरा सा बाहर लेके आओ, मतलब कि यहां से ना कट करके यहां से कट करवाओगे, तो यहां से कट करवाओगे तो ये प्लेन भी किसके पैरेलल, इसके पैरेलल हो जाएगा। उस केस में क्या होगा, ये यहां से कट कर जाएगा, ये पॉइंट यहां से कट कर जाएगा, तो फिर वो डायमीटर नहीं होगा। जरूरी नहीं है कि डायमीटर होगा, हो भी सकता है, नहीं भी हो सकता है। आई होप इट इज क्लियर। रोहित शर्मा, सो इट इज नॉट इंपॉर्टेंट दैट व्हेन यू आर गोइंग टू फॉर्म अ पैराबोला, तो मैं थोड़ा अंग्रेजी में भी बोल दूं, हिंदी वाले लोग को तो समझ में आ गया होगा. It is not important that when you are going to cut the cone such that it is parallel to one of the generator, it is not mandatory that you will get always the diameter of the circle. No. So in this model I have the diameter of the circle because this side and this side are exactly equal, but always no, it is not always true. Suppose this section plane, instead of this, if you make a little far away here and cut it like this, so this plane, so suppose this is the cutting plane, this cutting plane is parallel to this end generator. So if you cut it, again you will get the parabola over here, but this distance will be only here. So it is not important that you will always get the diameter, you may get here also, you may get here also. So it depends. The condition is that it should be parallel to one of the generator, that is it. Understood? Rohit Sharma, clear? Okay. Now let us go for the hyperbola. The same thing I have shown it by this figure. You can see that this is exactly parallel to the one. See, ये parallel है इसके. Correct. So this is how you are going to get it. Fine. Next, for hyperbola, let us go for the hyperbola. बताओ यहाँ तक सबको क्लियर है? तो चलो हाइपरबोला भी हम आपको बना के दिखाई देते हैं. So I have the model, just I need to put the paper. So till then you draw it. मैं जब तक इसका setting कर देता हूँ. See, hyperbola. So I have the cone. You can see that. Now this section plane is exactly parallel to the axis. आप देखो, ये जो section plane, it is exactly parallel to the axis, isn't it? So that means this angle is what? So this angle is your alpha. So how the section plane has been inserted? So the section plane is exactly parallel to the right here. So I can say that this line and this line is exactly parallel. That means beta will be how much? Here it will be beta is your 0 degree, isn't it? So beta is your 0 degree, correct? That means here you can see that beta is equal to alpha. That means I have tilted a little bit more. So beta equal to 0 degree is the one of the condition, but if you decrease the angle from alpha up to 0, you will get. That means if I talk about the condition, so since I have the model of beta is equal to 0, so if beta is equal to 0 but less than alpha also, you will get hyperbola. That means here beta is, see, in the first case beta was 90, then I have decreased from the 90, then I made it equal to alpha, and now beta is decreased from alpha, but it can be also equal to 0 degree. So the model in my hand what I have kept is beta is equal to 0 degree because this section plane is parallel to the axis of this parabola, axis of this cone, right? ये हो गया, correct? So let me complete this one now. So let me complete this one. Correct? So again you can see that the same points will be there. What? One point will is here, right? Another point is diametrically opposite, the same thing, and there will be a point here, isn't it? So एक point यहाँ पे base को cut कर रहा है, one is vertically opposite and there is one point, so there will be smooth curve. This is the hyperbola. I hope things are clear. Isn't it? राइट. सो आई कैन नॉट यूज रेडीमेड फिगर्स फॉर दिस बिकॉज यू विल बी अनएबल टू ड्रॉ. अगर इसका हम रेडीमेड फिगर बना देते है ना कि देखो ऐसा होता है, आप बना ही नहीं पाते, राइट. सो दैट मीन्स आई हैव कंस्ट्रक्टेड इट, you have understood it, and then you are have that much confidence. If I copy and pasted, right, copy paste कर देते और बोलते बनाओ, you will be unable to draw it कि कैसे बना है ये चीज, because you will not have that kind of visualization how it is cutting and how basically things are going. So that is one problem. So that is why I never use ready-made figures. Rare means if it is required then I will use, otherwise most of the time I draw myself, है ना. खुद से बनाने से क्या होता है, चीजें समझ में आ जाती है. क्लियर? Right. So what you can see over here is circle. Here beta is how much? 90 degree. Ellipse, this angle was beta, so beta is less than 90 degree but greater than alpha, right. So alpha is nothing but the this angle. So अगर ये axis है ना ऐसे, so this angle is your alpha, isn't it? So this angle is your alpha, isn't it? So alpha beta 90 degree. Here beta is equal to alpha because these two lines are parallel to each other. Here beta is less than alpha but it can be equal to 0. So this is the hyperbola, parabola. You can see that for parabola this flaring and for hyperbola this flaring is different, isn't it? ये देखो ये इसका जो opening है and this opening, so this opening is more for hyperbola, isn't it? चलो लिख लो इसको. If you are done then please let me know. ठीक है, हो जाएगा तो बताइएगा आप. Done everyone? Okay. So पवार ओमकार क्लियर, पवार ओमकार, ठीक है. तो चलो अब एक चीज आप ध्यान से देखो, जस्ट लुक एट वन थिंग. You can see that for a circle and for the ellipse all the generators are getting cut, right. So इसमें जितने भी generators हैं सारे कट हो जा रहे हैं, but for parabola, ellipse, sorry hyperbola, so only part of the generator is getting cut, so only this much portion is getting cut, right. यानी कि for the देखो पूरा का पूरा जितने भी आपके पार्ट्स हैं, है ना, पूरे इस कोने से लेकर के इस कोने एवरीथिंग इज गेटिंग कट फॉर. सो note for circle and ellipse, for circle and ellipse, section plane cuts all the generator, section plane cuts all the generator, isn't it? Cuts all the generator. Second, a hyperbola becomes a rectangular hyperbola, when 2 alpha is equal to 90 degree, that is apex angle is 90 degree, that is apex angle is 90 degree. B, section beta is equal to 0 degree, that is section plane is parallel to axis of cone, parallel to the axis of cone. And third, section plane must not pass through apex, section plane must not pass through apex. Right. So these are the conditions. So let us see as an example. I will show you. Right. For example, right. So what you can see here, this angle is your 90 degree, correct, right, and beta is equal to 0 degree. So what is beta equal to 0 degree means? So beta equal to 0 degree means the section plane must not pass through the apex. So let us say like this. Correct. So when it is done, then we can complete right. So you can see that here, this is one, this is vertically opposite, and this one, this is rectangular hyperbola. Just check it out, बनाइए इसको. Correct? Chalo. Third, now what you might think that what is going to happen if the section plane is passing through the apex, correct? So, if section plane passes through, if section plane passes through apex, then अगर ये apex से पास कर जाए तो क्या होगा, right? So if the section plane passes through the apex, so that means section plane will be like this. Section plane will be like this. It is passing through the apex. So if the section plane passes through the apex like this, correct. So let us see what is going to happen. Right, see, you can see that the section plane is passing through the apex, isn't it? So the section plane is passing through the apex. Clear? ठीक. Now if the section plane passes through the apex, so what is going to happen in this particular case? So let us see. So in this particular case, so this will be your section plane. Fine. So what is going to happen? So in this particular case, you can see that this is one cutting point, another cutting point, and here is one cutting point, isn't it? See, this is the base. So one point is cutting over here, isn't it? आपको दिख रहा होगा शायद. Just one second. Right. Now see. So this is one cutting point, another cutting point, another point is here. So total 3 points. Now let me remove this one. Correct. If I remove this one, so what is the shape you are going to get? You are going to get a triangle, isosceles triangle. In particular, in this particular case, I have an equilateral triangle. It is not that, so it is an isosceles triangle. It is not important that every time you will get isosceles, but it is sure that you are going to get a triangle, because this is a sharp edge. It is not a smooth curve, it is a sharp edge. So therefore, what is the shape you are going to get? So the shape I am going to get is something like this, isn't it? Correct. So what is you are going to get? So then a triangle is formed. A triangle is formed. So what we have done till now? So we have divided the we have done all the conic sections, right? So जितने भी possible conic sections हो सकते हैं हमने सारा कर दिया इसके अंदर, right? So all the kind of conic section, that means I have cut the cone in all the possible ways. अब इसके अलावा कोई भी way से cut करोगे तो इसी में से कोई एक figure मिलेगा, right? So that means if you are going to cut the cone in any of the format, right? So the number of figure that we have drawn here, you are not going to get anything other than this. So either you will get the triangle or you will get the parabola, ellipse, hyperbola and all those stuff. Other than this, you are not going to get any new figure, right? So this is what it is called as conic section, defined as section of cone. So that means when I am going to section a cone, or when I am going to cut a cone at various angles with the cutting plane, I am going to get the various shape. So this shape are basically called as conic section, right? Clear, everyone? So that was the first part. So just one second. Okay, fine. Second one, conic section defined as locus of point. Conic section defined as locus of point. I hope everyone is following it. Right. So let me, so this is your basically your, the first figure is about circle and ellipse. The second figure is about parabola and hyperbola. Next figure is for rectangular hyperbola. Next is for the triangle. करेक्ट, ओके डन एवरीवन, आगे चले, जल्दी बताओ, जल्दी जल्दी हाथ चलाओ, हो गया तो बताओ। Okay, so done everyone. Next, conic section defined as locus of point. See, suppose this is line is DD dash, right? So this DD dash, it is called as directrix. DD dash, इसको बोलते हैं directrix, correct? Similarly, this is at 90 degree, you can see that. So this point is C and this point is your C dash. So CC dash, it is called as axis. CC dash, it is called as axis. So directrix and axis are mutually perpendicular to each other. F, it is called as focus, and this point is always fixed. It does not move. Means if I show you here, so let us say this is your F, fixed point, F focus, correct? Now what I am going to do is, let us consider a point such that, let us consider the point in the plane such that the distance of the point from the focus and from the directrix, so let us say this point is E, and let us consider this is the point P, and this point is movable, that means it can move in any direction, correct? So it is also known as locus, right? So I am going to consider a point in this plane, right, such that it is the ratio of the distance of the point from the focus and from the directrix bears a constant ratio. That means PF, this point is such that PF upon PE is always constant, correct? So that means this point is going to move. So I have taken one point in this plane, anywhere you can take. So the distance of the point from the focus and the distance of the point from the directrix. So if I find the ratio, it has to be constant. That means when the point is moving in the plane, this ratio must not change. For example, if I say PF upon P is equal to 1.5, suppose. So if PF upon P is 1.5, means when I am changing this position of the point, let us say when this point is over here, right, so when this point is moving and it is coming over here, this point P is over here, so E will coincide with C such that this PF upon P is still 1.5. Similarly, if the point is over here, then the distance of the point from this focus, the distance of the point from this directrix and the distance of the point from the focus is still the same, right. So here it will be your E 90 degree. So that means this point is moving such that PF upon PE ratio is always constant, and this constant ratio is called as eccentricity. It is called as eccentricity, right. So when I am going to join this point, so I am going to get a curve, right. So when I am going to join this point, I am going to get the curve, and this curve is basically called as conic. This curve is called as conic, and when the conic is intersecting the axis, it is called as vertex, and it is shown by V. So what is V? V is your vertex. So vertex is nothing but the point of intersection of the conic with the axis, right. So what is vertex? So it is a point of intersection of conic with axis. Correct. So this is your conic. So how we are going to define this conic mathematically? Sir, is this lecture number 2 or 3? Lectures are not uploaded. Milu John, welcome back. Milu John. So this is lecture number 2, second. This is the second lecture, right. So vertex. So what is the meaning of this? How you are going to define conic? So conic is the locus of point. What is the meaning of locus of point? That means a point which is moving in a plane. Locus of point, है ना? So how you are going to define conic mathematically? So conic mathematically can be defined as it is the locus of point which moves in a plane such that the ratio of the point from the focus and the directrix bears a constant ratio, which is called as eccentricity. So I will write it, the definition of the conic. I hope the things are clear, isn't it? Conic section as a locus of point. So a conic is defined as the locus of point which moves in a plane, such that the ratio of the distance of the point from focus and that from directrix is always constant, known as eccentricity. Correct. So I don't know why the students are joining so late today, because I can see that there are so many students who are asking which lecture, when the class started. So once done, please tell me. संडे की वजह से, अच्छा संडे मीन्स हॉलीडे, इज इट? ओके, नो प्रॉब्लम. ओके, टेस्ट्स है ना, क्लास टेस्ट्स. Done? Okay. Fine. Okay. देखो, so this point है ना has to be moved in a plane such that the distance, ये distance और ये distance, right? Fine. ये distance क्या होना चाहिए? It is equal, correct? So similarly, as the point is moving, so this distance and this distance ratio will be same. Ratio same होना चाहिए. अब जैसे कि 1.5 है, ठीक है, तो 3/2 भी हो सकता है ना? इसी तरीके से इट कैन बी 6/4 ऑल्सो, करेक्ट? तो ये 6 हो सकता है, ये 4 हो सकता है, या ये 3 हो सकता है, ये 2 हो सकता है. सो द रेशियो शुड बी कांस्टेंट, राइट? So you have to choose those points such that this distance and this distance is always equal. So there can be n number of points where the ratio is same, है ना? 3/2 भी 1.5 होता है, 6/4 भी 1.5 होता है, correct? So on. Suppose this is 3, this is 2, this is 6, this is 4. तो सारे points को जोड़ोगे, you are going to get conic, right? Now, so mathematically, how you are going to show it? So mathematically, eccentricity E is equal to distance of point from focus upon distance of point from directrix, that is PF upon PE, correct? PF upon PE. So we have three cases. What are those three cases? So case number one, E is greater than 1. If E is greater than 1 means PF upon PE is greater than 1, means PF is greater than PE, correct? So then, so that means the distance of the point from the focus is greater than the distance of the point from the directrix, right? So that means something like this. So this is your D, okay. So that means here this P, this is F, and this is, right? So in such case a curve will be traced like this, isn't it? So a curve will be traced like this, correct? So this curve is called as hyperbola. Then at E greater than 1, hyperbola. So such curve is called as hyperbola. एग्जाम में यही पूछेगा आपसे, है ना, कि E is greater than 1, what this curve is called as? It is called as hyperbola. So where we find its application? So this is an important. It is called as hyperbola. Application: designing of cooling towers, flower vases, correct? So what is the mathematical equation? Mathematical equation: x square upon a square minus y square upon b square is equal to 1, where b square is equal to e square minus 1 into a square, and we know that what is E? It is nothing but your eccentricity. So this is basically few things that you have to remember, right? So this application is also important for exam. Formula is not that important, but yes, application or for E greater than 1. So that means if PF is right. So if E is greater than 1, the conic is called as hyperbola. So in this case PF will be greater than PE. So the curve is called as hyperbola, correct? So this is case number 1. Case number 2, E is equal to 1, correct? So if E is equal to 1, it means PF upon PE is equal to 1. So that means PF is equal to PE, correct? So PF is equal to PE means what? These two distances are same. this is E, this is focus, correct? Hey. This is E, right, this. So then at E is equal to 1, the conic, it is called as parabola. This conic is called as parabola, correct? So application, where we use, where you can see the parabolic. So application, this is the trajectory of object under gravity, correct? Next, parabolic mirrors, reflectors, etc. Parabolic mirrors, reflectors, etc. Dish antennas, correct? So these are the few examples, and some mathematical equation, y square is equal to 4ax, correct? So this is your parabola. Case number 3, eccentricity is less than 1. Fine, clear? Now case 3, so if E is less than 1, PF will be less than PE. So PF is less than PE. Correct. So then at E less than 1 it is called as ellipse, right? It is called as ellipse. It is called as ellipse, correct? So application: bridges, arches, elliptical gears. Fine. Mathematical equation: x square upon a square plus y square upon b square is equal to 1, where b square is equal to 1 minus e square into a square. This is ellipse. Clear? Note: at e is equal to 0, b square will become a square. So therefore note it down फटाफट से. So therefore x square plus y square, it is equal to a square. So this is nothing but your circle, right? So where you find the application, right? So therefore at e is equal to 0, I am going to get a circle, right? So where I am going to find the application, right? So application: circle, lot of application, wheels, discs, diaphragm of speakers, diaphragm of speakers. So there are n number of examples. Circle, isn't it? Sir, kindly provide sufficient to copy after you are done writing. Yes, I am giving, इसलिए मैं पूछ रहा हूँ. Let me zoom out so that if anybody missed something, they can write. ठीक. So once done, please let me know. Fine. Okay, now see. Fine. So I hope everybody has written. Now let me show you some slides. देखो, ध्यान से देखो. This is the application of the hyperbola. You can see that this is called as cooling tower. So this curve is your hyperbola, correct? This is your hyperbola. So in hyperbola application, what you have written? So in hyperbola application, see here, in hyperbola, cooling towers, flower vases, isn't it? So this is for the hyperbola case number 1, cooling tower and flower vases. See here. So this is your cooling tower, correct? So cooling tower, so this is hyperbola. Flower vase, hyperbola, correct? Flower vase. Next, for parabola, trajectory of the object mirrors dish antennas, right? So case number 2, this is for the parabola. See here, you can see that this is the water coming out. So this is the trajectory of the object or trajectory of the water particle in the gravity, under gravity. This is your parabola, right? So this curve is your parabolic curve. Clear? Fine. So this is called as trajectory of the object. So here object is nothing but the water particles. So trajectory of the water particle is your parabola. This is your dish antenna. This is parabolic. This is your parabolic dish antenna. Correct? Next, for ellipse, bridges, arches, elliptical gears. Correct? Bridges, arches, elliptical gears. See, this is the bridge, elliptical in shape, part elliptical, so rest part is like this, right? So this is your ellipse, correct? Gears, so this is your elliptical gears, this is your elliptical gears. Fine. So circles, you know, wheels, disc, diaphragm, and etc. Now there are few things that you have to understand or note. Now, noteworthy points. Noteworthy points. First, about ellipse. So there are 3 points that you have to remember for ellipse. This is the ellipse. So ellipse has got 2 focus, one focus here, another focus f dash. This is your v dash, this is your v. C, c dash. Say d, d dash, d, d dash. V1 dash, V1, and this is O, correct? So this is an ellipse. So suppose there is a point which is moving over here. Consider any point. This point, it is moving in either ways, correct? So here VV dash, it is called as major axis. It is called as major axis. V1 V1 dash, it is called as minor axis, correct? F dash, these are basically your focus. Okay, so focus we know that, so we don't have to write. O is your center of ellipse. Correct? This point is moving. Sir, where we use elliptical gears. See, elliptical gears are used in the automatic machines. Maybe it is used in textile industries, it is used in printing industries, right? So there we used. Correct? Okay. So the first point, we are not going to prove any point, right? So proof nahi karenge. Now see this point. Now see how the basically you can see that how it is basically formed. See, just to take 2 nails, do nail lo or 2 screws. Screw. So put 1 screw over here, another screw over here. 2 screw, get 2 screws or 2 nails, fix it here. 1 nail here, 1 nail here. You take a thread, one end of the thread wind here, another thread of the another end of the thread wind here, such that there is a slack in the thread. Now to tighten it, what you will do? You will take your pencil or pen and you will tighten it like this. So when you tighten it and make the curve, you will get a ellipse. Get an ellipse, right? So what are the few points that you have to remember? The first point, right? First point. The distance of the point from the 2 foci is always equal to major axis. That is the first point, right? So you have to remember this, you have to keep these points in mind, you don't have to derive it, right? So the sum of the distance, the sum of the distance of the point from foci, foci means plural of focus, is always equal to major axis, is always equal to its major axis, that is PF plus PF dash is always equal to VV dash. So direct question will come, right? So always remember, right? So PF plus PF dash, it is always equal to VV dash, right? That is major axis. Second point, the distance of any end of minor axis from any focus is, what does that mean? It means that if I consider the distance of the minor axis, right? So the distance of the minor axis. So what are the minor axis here? So this is one distance of the one end of the minor axis from any focus, right? So the distance of any end of minor axis from any focus is always half of major axis. But obvious, you can see that V1F plus V1F dash, it will be equal to VV dash, because this point when it moves and it intersect at V1, so this distance, that means from here to here, what is the total distance? It is always equal to major axis. So this distance and this distance will be equal. That means you can see that this distance, this distance, this distance and this distance all will be equal, isn't it? So this distance plus this distance is equal to major axis. So this distance is how much? It is half of major axis, is always half of major axis, that is VV dash by 2. Clear? Right. And the third, eccentricity E. So eccentricity is always less than 1 for ellipse, correct? बताओ, ये तो दोनों point clear है? So if any point is not clear, just let me know, right? So I am not going that much fast, I am going at the mediocre speed, and I hope I am giving you the ample amount of time to understand as well as write. If you have any problem, if you have bigger problem, major problem, then we can discuss after the class, right? But if you have a minor problem or something is left, you can just ask me so that we can clear it, right? So I hope you are able to understand the subject and you are finding a little bit interesting also, right? So application and all those stuff, correct? So note it down. Done everyone? Any doubt till here? Any doubt anybody? बताओ, कोई किसी को डाउट है? समझ में आ रहा है कि नहीं? Done? Fine. So what I said that the distance of any end of the minor axis. So that means this is V1 is your one end of the minor axis, V1 dash is another end. So how much is this distance? So you know that V1F plus V1F dash, right? What you can say that, see here, V1F, see the figure very carefully, V1F, it will be equal to V1F dash, it will be equal to V1 dash F dash, which is equal to V1 dash F, correct. So all will be equal, correct. Now I am asking what is this distance, right? So this is how much, correct, this is the question. We know that as V1F plus V1F dash, V1F plus V1F dash, it will be how much, VV dash, isn't it? V1F plus V1F dash is how much, it is VV dash. From the first point we know that V1F and V1F dash both are equal, so therefore I can say that 2 times of V1F is equal to VV dash. So what is your V1F? V1F is equal to VV dash by 2. So this is what I have written here, this is what I have written here, it is half of my x. You can say simple maths, you don't have to do anything, it is just simple maths. Batao, clear hai? ऐसा क्या करेंगे? Fine. See, this point is moving, so at this point this is basically P point, because this point is moving, ये move करते करते कहाँ पे आ जाएगा, here, again it will move like this and again it will come over here, isn't it? इस तरीके से point घूमेगा, because the point is movable, so from here it will come here, then what is the distance of this end? Similarly when it will come here, again this point P will coincide here and so on. Clear है ना? बताओ clear होगा कि नहीं? So now I think it is clear. This point is movable, right? एक बार point यहाँ है, दूसरी बार point कहाँ पे जाके रुक जाएगा, V1 पे. So what is the distance of the end? Like this. Fine. Next, if you see the diagram, eccentricity, बताओ कोई doubt और किसी को? Now see, here which point is this one? Now see, I am redrawing. You can see that the first C, then V, then F, then O, then F dash, then V dash, and then C dash. So that means here we have C, then we have vertex, then we have focus, we have center, we have F dash, we have V dash, and this is your C dash, isn't it? This is how the figure is we have drawn. Now this distance is how much? It is your FF dash, right? So I am not proving anything because it is not required for objective paper, VV dash, and this distance is how much? It is CC dash, correct. So how we have found eccentricity? We know that eccentricity, one formula was PF upon P. Another way to form eccentricity is what? Right. So how we have found eccentricity? Now we know that eccentricity for ellipse is less than 1. So how we are going to find this less than 1? That means a number will give you less than 1 if denominator is greater than numerator. If denominator is greater than numerator, the value will be less than 1. So eccentricity is also found with this formula, VV dash upon FF dash upon VV dash. So FF dash, if I divide by VV dash, obviously the value will be less than 1. This will also give you eccentricity, and the same thing is VV dash upon CC dash. So that means if I do VV dash upon CC dash or FF dash upon VV dash, you will get the same eccentricity that we are going to find with PF upon P. So these are the 3 important points that you have to remember, right? So this is for the ellipse, correct. So this we have found for the ellipse. Now the second is for the hyperbola, the last one of this chapter. So this chapter will also be over, then we will go for the 4th chapter. करेक्ट, हाइपरबोला. क्लियर? ऋत्विक नयन है ना, ऋत्विक नयन, समझ में आ गया चीज? एनीबॉडी, एनी डाउट? सो इफ यू हैव कॉन्सेप्चुअल डाउट और you think that it will be not get cleared in during the running class, you can ask me after the class also. और because I am making everything clear, इसमें ऐसा कुछ है नहीं कि जो आपको फंस जाएगा मामला कहीं पे, right? So I am not showing you the derivation, but yes, I am telling you the points. So some common sense and some logic reasoning also. For example, here, if you, I have proved it here also, right? I can prove this also. So it is not required the proof. Only the thing you have to remember the points, right? So some logic reasoning if you do, you will come to know. Okay, hyperbola. तो चलो हाइपरबोला फटाफट बना लेते हैं. क्लियर टिल हियर एवरीवन? नोट कर लिया इसको? इसेंट्रिसिटी डन. इसेंट्रिसिटी, clear? Shall we move ahead? Clear? Okay. Now coming to the hyperbola. Okay, first you draw till here, otherwise you will get confused. कैसे बना दिया हमने? This is O, right? Let us say this is X, this is Y, so this is your X dash, and let us say this is your Y dash. पहले इतना बना लो. So draw it till here. So are you able to understand? So we will finish this third chapter today, and we will use the fourth chapter introduction as well. So again tomorrow we will finish fourth chapter. Done? Now at any convenient distance, right? So this is a vertex V, this is C, this is C dash, this is your V dash, and let us say there is a focus F dash. So what you can see here, so this is the hyperbola, correct? So pink color का जो बना है इसी को बोलते हैं hyperbola. This is called as hyperbola. Fine. Okay. So here x x dash and y y dash, it is called as asymptotes. It is called as asymptotes, correct? Next we have v v dash, it is called as transverse axis. It is called as transverse axis, correct? So it is called as transverse axis. O, it is called as center of hyperbola. Center of hyperbola, correct? And let us say this is your A, this is B, let us say this is A dash, and let us say this is B dash. So A dash B dash, it is AB and A dash B dash, it is called as directrix. Correct? Fine. So there are again 2-3 points for the hyperbola. Correct? Hyperbola. Now the difference between the ellipse and hyperbola is that in ellipse focus is nearer to the origin. See, focus is nearer to the origin means what? You can say that this is center. So center के नजदीक focus होता है in ellipse. So in ellipse focus is closer to the center. ये क्या है? But in hyperbola focus is farthest from the center, right? So that is the difference between the ellipse and hyperbola. In hyperbola focus will be closer to the closest to the origin or the center, and in hyperbola focus will be farthest from the center of the hyperbola. Clear? Okay, यहाँ तक बना लिया. So let us take a point P, and this P point moves. This P point moves according to this, right? So it will move like this. So again we have few points. The first point is the difference. So in ellipse it was sum, now here it is difference, right? So in ellipse you can see that it was the sum of the distance. Here it is the difference of the distance, the difference of the distance, the difference of the distance of the point, from foci, right? So that means the difference of the distance of the point from foci is always equal to transverse axis, is always equal to. So these are the points you have to remember, you don't have to derive it. Transverse axis, that is PF minus PF dash is equal to VB dash. So this is one important thing that you have to remember, right? So in the ellipse it was PF plus, so PF plus PF dash was VB dash in the ellipse, but in hyperbola it is PF minus PF dash is always equal to VB dash. So this is the first point that you have to remember. चलो यहाँ तक लिख लो फटाफट, हो जाएगा तो बताओ. If it is done just let me know. Done? Okay. Second point. If the angle between asymptotes, if the angle between asymptotes is 90 degree, correct? So that means if these angles, right? So this angle, correct? So if the angle between asymptotes is 90 degree, correct, then hyperbola thus traced, then hyperbola thus traced is called as rectangular hyperbola, is called as rectangular hyperbola having eccentricity E is equal to root 2, correct. So, if the angle between the asymptotes, so for example, so this is x and this is y, how much angle it is making? You can see that it is making 90 degree, right. So, the curve that will be traced here, it is called as rectangular hyperbola. Correct. Now, so mathematical equation of any rectangular hyperbola. So, mathematically x into y is equal to constant. So, if any curve follows x into y is equal to constant, it is your rectangular hyperbola. So, any equation, mathematical equation, if x into y is equal to constant, it will give you rectangular hyperbola. For example, Boyle's law, that is PV is equal to constant, it will give you what? Rectangular hyperbola. So, rectangular hyperbola have the equation x into y is equal to constant. So, for example, Boyle's law, PV is equal to constant at a given temperature. So, it will trace a curve called as rectangular hyperbola. Clear? Clear everyone? ठीक है. Third and the last point of this chapter, eccentricity E greater than 1 होता है, correct. So, just now what I said is, that if this is O, so this is your C dash, this is your V dash, and this is your focus F dash. This is your C, this is your V, and this is the focus, because focus is always farthest. So, this distance is your CC dash, this distance is your VV dash, and this distance is your FF dash, correct. So, I said earlier that eccentricity is defined as PF upon P. Another way to form the eccentricity is that eccentricity should be greater than 1. So, greater than 1 means numerator should be greater than denominator. So, it will become VV dash upon CC dash, which will be equal to FF dash upon VV dash. So, this is how we find the eccentricity. right? So with this we finish this chapter as well. आप लोग लिख नहीं रहे हो क्या, सिर्फ फोटो खींच रहे हो? सब स्टूडेंट्स फोटो बोलते सर थोड़ा लास्ट स्लाइड दिखा दिए, फोटो खींच लेंगे, ये दिखा दीजिए, फोटो खींच लेंगे। सचिन चल क्या रहा है, राइट? सो फोटो खींच के क्या आप लोग करते क्या हो? पीडीएफ बना के रखते हो क्या? सब लिखते कम और फोटो खींच के रखते हो क्या? वाई यू टेक द फोटो? व्हाट इज द रीजन बिहाइंड टेकिंग द फोटो? सब चीज़ अब लिख ही रहे हो कॉपी में लिख रहे हो कि सिर्फ फोटो से काम चला रहे हो? सो व्हाई यू वांट फोटोज? फोटो क्यों छूट जाता है, या फिर कुछ तो होगा रीजन? नहीं, ओके। So we have finished chapter 3. Chapter 3 is done. Coming to the last, sorry not last, chapter 4, engineering curves. Chapter 4, engineering curves. Right, done with, fine. ओके ये पेज भी खत्म हो गया। सो चैप्टर नंबर 4, इंजीनियरिंग कर्व्स। सो लेट अस फोकस ऑन द क्लासिफिकेशन फर्स्ट। First one, it is called as plane curve. Plane curve means curve in a 2D plane. Plane curve, that means curve traced in 2D plane. इसको बोलते हैं plane curve. That means curve traced in 2D plane. So plane curve, it is classified into few groups. Right? First one, it is called as cycloidal curve. It is your cycloidal curve. So in cycloidal curve, we have cycloid and trochoid. Cycloid and trochoid. We have epicycloid and epitrochoid. Epicycloid and epitrochoid. Hypocycloid and hypotrochoid. Hypocycloid and hypotrochoid. Second one, it is called as involute. Third one, it is called as spirals. In spirals, we have Archimedean spiral, Archimedean, we have logarithmic, and we have golden, and finally we have space curve. We have space curve. What is space curve? So curve traced in 3D, curve traced in 3D plane. So in this we have only single, that is called as helix, helixes, helixes. In helixes we have cylindrical helix, we have cylindrical helix, and we have conical helix, we have conical helix. ठीक है.